Hello. Good morning. Can I start? Okay, good morning. I'm Laurent from Rakuten Institute of Technology, which is a research department of Rakuten. And there will be two talks now, mine and Adiyan talk. So this talk is about the future of artificial intelligence. There was another talk just previously about artificial intelligence, which was mostly technical, and mine is less technical, and it's more about some issues that are not very often dealt with when we talk about the future of AI. I started my career by being an engineer on projects using neural networks. And so since then, I've been watching the evolution of artificial intelligence. And here I'm showing different trends about the use of the words artificial intelligence and neural network. And you know, for any technology, we can usually observe what we call the hype curve, which is different periods, where the first period is when there are great expectations, and then some disillusion, and the curve goes down, and then some plateau of productivity. So this is a theory, but these curves are actual curves about the frequencies of terms, words in books. So this is calculated by Google Books Ngram Viewer, and the other one by Google Trends. This is quite interesting. So we see a kind of hype curve for artificial intelligence, and we also see thank you. We also see the rise of neural networks, and we can also observe that the word machine learning, their frequencies reaches the one of artificial intelligence, and I think it's because what we used to call artificial intelligence is now called machine learning. So, and what we now call artificial intelligence is something more advanced. So, machine learning words tend to replace what artificial intelligence was. And of course, we see the rise of deep learning. So, the previous talk was especially about that. So, this is the most recent technique that brought great expectation about artificial intelligence. So we could say it started in, I will talk about tasks where computers outperform human performances. So it started from 1997 when a computer became stronger than the chess champion, Garry Kasparov. So that's why quite a shock. But it was the results of mostly brute force, which is trying many combinations just by using great computer power. For Go game, as was said in the previous talk, it's much more complicated, and we can not just look at the different combination. This is a domain where some researchers in Facebook are now using deep learning. And that was also mentioned in the previous talk. This is about not solving a very specific task, but learning how to solve a problem that just appears. We didn't know anything about it previously. So here the computer just has the input, which is the pixels of the screen, and knows about the scores, and it learns how to play and how to play well. So this is a more advanced feature. That was said previously. So this is some overlap, but I will go much further in the future next. So more and more tasks we consider better achieved by human in the past are now very, very well achieved by computer. And so it started with backgammon, then chess, then Jeopardy, then now, recently, at image recognition, we see that the computer performances are become better than the one of human beings here in 2015. So it seems that for any new task, computers will outperform us. So, but for any specific task. And the next frontier is now having a real dialogue in natural language. In in 1984, when Steve Jobs presented the Macintosh, at some point the computer started to speak. And it was really an amazement in the audience. People were screaming. You should have a look at the video. It's really incredible, just because the computer was speaking. But since then, so it was a very crappy voice synthesis. So since then, there has been much improvement. So we have very good speech recognition, voice synthesis, but computers are not at all really able to have a real dialogue. So this is something that doesn't exist yet. And if we see that on the timeline, we can distinguish between narrow artificial intelligence and general artificial intelligence. Narrow AI being about solving specific tasks, like recognizing what's inside an image. That's very, very difficult, and the performances are outstanding. We didn't expect that. But it's about specific tasks, which are well-defined, like saying that in this picture there is a cat. Okay, that's very difficult, but it's very limited in a limited domain. Then knowing how to deal with an unknown problem, you don't know the rules of a game, for instance, is another step. And the next step would be a true generalization, being able to have a dialogue about anything using natural language, sorry. And this is called the Turing Test. The Turing Test is about whether you can distinguish between a computer and a human when you have a discussion with it or him. And this is something that no computer passed yet, and we don't know when it will happen. So many people say that it will happen in a few years or decades. Nobody knows. So that will be a major step. And some people consider that when we will pass the computers will pass this test, we will be able to say that computers as intelligent as humans. At least this is a way to measure intelligence compared to the human intelligence. But now many scientists go further, much further than that. So we're not there yet, but they go further and they think about what will happen when computers will be more intelligent than human. So they call that super intelligence. And this is a time where computers would be able, as they expect, would be able to create other computers by themselves, so doing self-replication. And some scientists even say that computers will become a new species that might replace the human species. So we could say that there is a test to evaluate human intelligence, which is a Turing test. But what would be the test to evaluate superintelligence? So one of the scientists who defines superintelligence says that superintelligence means an intellect that is much smarter than the best human brain in practically every field, including scientific creativity, general wisdom, and social skills. Okay, so we know how to measure natural language capacity using Turing test. How to measure general wisdom? Probably there is no way, so that's kind of difficult. So from all these talk and anticipations appear many fears. So there was an open letters written by many well-known scientists to warn about the danger of artificial intelligence. And there are also huge expectations, and people look forward to a new civilization based on superintelligence. So now this is the most important part of my talk. Previously it was just something that was already well known, but I would point out a few major differences between natural and artificial intelligence. So it's impossible to predict exactly when different new steps in the performances of artificial intelligence will happen, but we can consider some fundamental differences. So let's have a look at that. First, the model we have about the human brain is of course an approximation. It's based on the knowledge we have of the physics at different levels. And for instance, it's now mostly based on the concept of neurons and synapses. And of course, there is a lot more in the brain So we cannot explain everything with that, but many people think it's enough to go as far as we want, but it is not. And probably, and it's for sure, in the next years we will have a better model, but it will still be a rough approximation, because this is what models are, representation of the reality. And we can see similar things with theories in science in general. You know that at the end of the 19th centuries, many scientists thought they were able to explain almost everything. There was just a small problem with like the constancy of speed of light, which was a slight problem they would solve. But then came the theory of relativity, and later the quantum physics, and everything was brought down. Not brought down because, well, the previous theories were okay, but there were approximations that the next theory show they just apply on a limited framework. So it's exactly the same with the representation of the brain. So I think it's something important to think of. Also, the human brain, in the reality, not the model, is inside a continuum at different scale levels and in the history of life evolution. It's connected, of course, with the different levels of the component of life, the cells, and lower than the molecules, the particles, and it's part of the human body, which is part of human society, and so on. And it has a very long history in the of life evolution. And if we have a look at the evolution of life since the formation of Earth, the apparition of humans is almost just now. So, from this observation, you can infer different things. You can say, okay, it just took a few years or a million years to create the human brain. So we can create an artificial brain. That's not so difficult. But we can also think that, okay, it just appeared a few million years ago, but it's the result of all the things that happened before. So when you try to create some artificial intelligence, you just start there, whereas for the human brain, it started there 5 billion years ago or more. And now, I think now this is the most important difference, the most fundamental difference between an artificial intelligence and human intelligence. Artificial intelligence will always be based on a formal system. So many people say that previously we had expert system and classic software programming that would create some intelligence. We could say everything about how it was created and how it worked. And that now that we have deep learning, neural networks, we don't know exactly what happens inside the neural networks, in the neurons. So that's different. That's not really like before. But I think that anyway, whatever the different components are, and even if you have some component is capable of doing some training by itself, it's still based on some formal logic, the logic of the algorithm for the training. And so there will always be a gap between the material world and this artificial intelligence, which is based on formal logics. Because of course you have the hardware support for a computer. You need also of course some hardware component. But as soon as you start doing software, you split yourself from the material world. And so everything then is based on bits or anything that will come later, like quantum bits or anything. But it will still be some elementary component which will be based on the use as a component for formal logics. And on top of that, there will be some software component, and the artificial intelligence will always be built on top of that. And so you will be able probably to create, to simulate many things that happen in the brain, like emotion, maybe intuition, maybe creativity, many things. But there will always be simulated things that will always be different from the real thing, because you could split down everything that happens here down to elementary component, whereas in the real world that doesn't happen like that. There is a continuity. So now, what about the predictions that people do about artificial intelligence? So for what happens today, we see, and that's a fact, that the computer outperforms human in many, many, many tasks, and in some places we didn't expect them. And it will go on for many tasks, well, like driving cars or anything. Computers will be better than us. But it will be for specified tasks. Then, if we talk about general AI, which doesn't exist really yet, which is about dealing with any type of new problem you don't know anything about, or having a real dialogue in natural language, which is passing the Turing Test. This is something that may happen in a few years. We don't know. Really, we don't know, I think. Many people say it will happen in a decade or more, but it's impossible to say. And for the next step, superintelligence, I think this is not really a scientific subject, a scientific question for now. So I won't give any answer to that, but I wanted to point out these different, very important differences between AI and natural intelligence. And so the big questions, you're only able to answer them by yourself. So which are, can human brain be considered as a machine? Because when you say that a machine will be equivalent to the human brain, it means the human brain is like machine. Many scientists think that. And will computer be able to experiment through emotion or even free will? And many scientists think so, but this is not a scientific question either. And will it be a new species? And could we transfer our minds to computer? Many scientists also look forward to that. So, of course, I have my opinion about all that, which is mostly no, but I don't know what you think. So that's it for me, thank you. I'm sorry, and now I will introduce next talk by Adiyan. So this was about artificial intelligence, but Adiyan will talk about how to combine artificial and natural intelligence, which is also something very interesting. Thank you.
Test. All right, thank you so much for Laurent to giving the kind introductions.
Sorry.
That's okay. So my name is Adiyan Mujibiya. I'm a research scientist at the Rakuten Technology. As Laurent mentions, we are the R&D organizations of Rakuten. We're working in a lot of different fields that I'm going to explain to you in the end of my slides. Hope you'll be excited about our organizations. So I'm going to talk about how we can combine what so-called artificial intelligence, which I believe is mostly a computational intelligence, because we're using a lot of computational powers and resources to do that, and how to enhance the human creativity. It's something that is a solely artificial intelligence really going to be hard to do. Imagine if you have to design a web page, and some people are really good at this. Is something as aesthetic, but imagine can you do that with artificial intelligence? It's going to be a bit difficult, right? But let's talk about that. Right, so I'm going to start about this stats from GitHub. Great, it's the deep learning toolkit released in the GitHub. So you can actually search for them in GitHub, and you can search for your preference. The top of the heap, it's actually the TensorFlow, which just released a week ago, I guess, but it's been running for a while in the development society within Google. It's very remarkable. Of course, this list is a bit biased because TensorFlow just get out for a few weeks, for a few days or a few weeks, but it's already gaining a lot of popularity. And after that, Caffe, a lot of people are using Caffe, especially for the ImageNet. If you wanna recognize what sort of objects inside an image is. And of course, it's pretty general, so you can basically train it with your model and to do your specific task that you want to achieve. And yeah, and this is the amount of the stars. As you can see, there's a lot of things out there. Oh, I forgot to mention that this trend is going very, very steeply. So from 2010 to 2014, this sort of a deep learning toolkit or machine learning toolkit is released for once every 47 days. Quite remarkable, right? But then coming through this year, when there is a couple of years back, and there is a contest. It's called the ImageNet contest, where people, a lot of researchers in the computer science are gathered together and then trying to achieve the best results in object recognition. And the deep learning techniques has been spurred as the top of the heap. And then people have been talking about this. And since 2015, almost every 22 days, the new deep learning toolkits out there. So given a lot of the technology advances and a lot of people are investing their time more into this, so it's the engineering toolkit is now, it's all about the choice and preference. It's about what you want to do and, and choosing the best tools, the way to do this. This is one way to engineer, the vision of the grand visions of the artificial intelligence. There's a lot of things out here. So in this graph, actually, I'm showing the GitHub the stats for each of the tools, forks, stars, and issues, right? So you can basically see how is it out there. It is very remarkable that the first and the second is from the academic society, and the third one is actually ConfNet.js, which is a JavaScript written language for this. So a lot of people also getting very, very interested on doing this online on the web, right? So all of this stuff, all of this technology, all of this toolkit, what do they exist for? Right? We know this well, this is a technology, really cool toolkits. Some people try, and build them and then try to run up in their machines, and then they have enough with it. Okay, I tried it already. It looks cool. I got a reasonable results on the handwritten recognition. That's it. But actually, there's a lot of things that can be enabled from this. We need to envision what sort of experience that we want to achieve, and then we can use all of those technologies. So, and this all has to be in the context of what we want to achieve, right? We just don't want to use that tools just in sake of the tools. But then at one point, all of these intelligence, like what I said previously in the start, it does not necessarily have to be artificial. There is some aspect that can be artificial, but there are a lot of aspects that should be referring to the human creativity. And I believe all of these two different sort of spectrum in the end of the spectrums can collaborate together to achieve a really better results and contents. So I would like to introduce one of the research from the MIT CSAL. It's called Soylent. It's published in 2010's UIST, User Interface Software and Technology Conference, which is one of the most advanced conference in our field. So you can see there's a project page over there in the video over there. All the credits goes to the MIT team. So it's a word processor with a crowd inside. So imagine, before I'm showing you the video, imagine when you're writing your paper or thesis or even your essay, imagine that you can actually use this inside your writing process.
Explores what's possible when we start embedding humans, paid crowd workers, into our interfaces. Soylent is an add-in for Microsoft Word that gets human help to support tasks that Word can't do well: shortening, proofreading, and open-ended editing via macros. It does this by recruiting workers on Amazon's Mechanical Turk service to solve hard AI problems for just a few cents. Each member of the crowd does a little bit of work, so it's like having tens or hundreds of people help you write your document. One of Soylent's features is called Shorten. Shorten helps writers cut down.
All right, so actually the function goes over there. I'm sorry for that. This is a plugin for Microsoft Word. And then when you come up with the a manuscript, and then you want to shorten it, and you want to crowd-proof it, you want to proofread it, you want to see whether you did some grammatical mistake or something like that. Of course, the built-in NLP-based tool is available over there, but sometimes it is much better to ask experts or ask anyone out there to give a second opinion. So it looks like an automatic tools, but it actually isn't, because what's inside, there's a lot of people out there that are investing their time to do this micro work. So we call this some sort of framework as a crowdsourcing. Perhaps you know already about this. And this is really remarkable because there's a lot of things we can do about it. So we have our own projects on working on this as well. So this is my paper. Sometimes when I write paper, we have a length constraint. So, okay, your paper should be 4 pages, so it should be 10 pages or things like that. But imagine if I come up with a lot of ideas, I came up with 15 pages or 20 pages, and then I want to, somehow shorten the contents out to fit with the amount of the page that is required to be published. And then, using this to zoom in and zoom out and things like that. And of course, it's not only during the making, the content making process, but it's also in the content's consumption process. Imagine if you're standing waiting for your train inside a station, right? And then you only have some few of a seconds to be able to read ebooks or be able to read or be able to watch movies. But of course, your time is limited. Then you don't want to watch the whole, I don't know, Lord of the Ring, three hours, right? You just want to see the digest, and how can you support them? Probably there's a lot of research in computer vision, image processing, and of course in LP to do this, shorten out the contents of text, of a video, things like that, but it doesn't have to be all automatic. Automatic is really good at doing some stuff, doing some scene segmentation, things like that. But deciding whether a content is good or not, is meaningful or not, is people are generally good and better at it. So artificial intelligence does not again necessarily to be all automatic, but we can combine all the wisdom of crowds to do this as well, and then combine it in a system, in a framework that looks like it is automatic, but it's actually not. It is very beautifully designed for the specific purpose. So we call this a crowded intelligence. It's not really that crowded, but there's actually in the background it's really crowded, but it still provides you some sort of intelligence for your purpose. But actually, yes, inside of it, there's a lot of computational intelligence happening. So when you do this with a lot of crowds, you need to collect all this feedback from the crowd, and you decide which feedback is good or not. So it's all about quality. How would you measure that the crowd is actually generally wise and generally know what they're doing? So so we do a lot of scoring in this part as well. So computational intelligence is playing a lot of roles, and we also can do this can use the automatic part of the artificial intelligence, like in deep learning, things like that, to actually quantify a feature. Humans are good at giving decisions of what X and what's Y, but when you try to ask people, okay, why do you think that is good, or why do you think that is bad, right? So it's very, very, sometimes it's very hard. It's something that a human not really optimize that for, arguably, right? So computers are very good at doing the quantifying of a feature. So like, given an image of a cat, like what they do in the object recognitions, they know what sort of the features that looks like a cat, like their eyes, how their nose and their mouth and their eyes are correlated to each other. They're really good at quantifying this sort of stuff. There's a lot of works in the deep convolutional neural networks, and even the newer branch of recurrent neural networks in doing this sort of stuff. The most recent trend is actually the image recognition, because it's high impact and high outcome as well. It's actually very interesting that we just barely touch the surface on this part. For image recognitions, you have one input, right? And then given some sort of a model, and you can map your input into one specific results. Well, like this. Of course, you can do a partial base. You can make a window out of. You can kind of like see your image frame, and then you can get some sort of understanding of what sort of objects are appearing in the image. So all the image credits are for the ImageNet database, right? But then there is another trials called the recurrent neural networks, and try to get some sort of an understanding of an image, not only the objects inside the image, but try to get a full caption of what's going on inside the image. It's like more of an understanding of what's going on inside the image. So for this, like you can see there's a really nice result of the caption of an image. It can tell a story. You can already think of a lot of different usages for this, right? Imagine if you just write a text and then the system come up with a fine video that collected from the web and makes a really nice video explaining your ideas. It's going to be really cool, right? There's a lot of other things as well. For sentiment analysis, given like a sort of a paragraph with a lot of different words and characters and text like that, and you will end up with mapping it into one, whether it's a negative or positive or neutral as outcome for that for sentiment. And for machine translation, you come up with a lot of inputs, a lot of sentences, a lot of words, and you come up with some sort of results, many text, right? And then for the video annotation as well, you have a breadth of a video, and you can split it based on the frames, and you come up with the results of what sort of video annotation might look like. For the RNN, the recurrent neural networks, so I would point out really interesting ideas here that it actually combines, it's really simple, it combines an input vector with a state vector. The input vector is red over here, and then the learn function is the green one in the middle, and to produce a new state vectors, the results up there in the blue ones. It's very interesting because, again, the blue one is to produce a new state vector. If you take a step back and think about it, it's actually very interesting because, you know, it's like letting the machine to think, right? So there's a lot of different trials out there to use deep learning, to use this convolutional neural network, to use the recurrent neural networks to actually generate stuff. So I cannot really show you one by one because of the IP and things like that. So a lot of people, folks out there, researchers, even hobbyists try to do this sort of stuff like Mozart-style music generations. And given a lot of inputs of the Mozart music style, they come up with the results that of music that looks like, that sounds like a Mozart-style music, which is really fun. And even TED Talks. Of course, the source is going to be speech, TED speech. Then we'll come up with the text that reads like a typical TED Talks. It's really interesting. I really urge you to read of this page. And Google have come up with the Google Inceptionism, which look at the images and then try to either map their features, the strong features inside an existing image, or even generate a totally new image based on the features. So it is something that is a new directive thing that really tells that the capability of the computational intelligence is going farther and farther ahead. But you know, the problem is how to make it more useful, right? So we can come up with all of this stuff, but it's good for just consumption and playing around one at a time. But again, how to make it useful? How we can kind of like fill the gaps and do this to fulfill our missions in our daily life. And there is, to give you some introductions on this, there's a very cool deep stereo paper from Google also. This is the link if you want to see, and then the video as well. I'm just going to show you the video. So what it does in the video, all the credits goes to Google, by the way, Google Research. Given that you capture a scene of a 360 panoramic display in a different places. So if I take the picture in that part and then picture in this part, and then the system will generate a novel point of view system that camera just looks in this part. So, right. So yeah, to predict new views from the already learned imagery. So yeah, so you can see in this part, this is like the input point of view, and then when you draw back, it looks like really smooth, as if you capture a video, but it's actually not. So some of these, so they fill the gap. So they fill the point of view visions for those kind of frames. So, right, you get the idea. Again, in my talk here, I would like to focus that combining the human-made and artificially created contents is interesting. It is something that, I would like the industry to catch up to this as a researcher. But of course, I'm in the industry as well, so we also make some sort of these tools. That we brushed it up and try to figure out what can be useful both for the society and of course for our business as well. It's about augmenting creativity, and one of the interesting things that we would like to see is for supporting people in their design iterations in the personal fabrication. So as you know, personal fabrications have been starting really actively by the 3D printer. It's much more value-wise and inexpensive, right? And people start to build their own models and things like that. But the problem is, how do we actually help their design iteration? How we help them in making their interesting stuffs. So one of the projects that we have is called Project Designers, is to help people make the tools. Like imagine if you try to, it's like just typical modeling. Of course, using the state of the art, you can create like how many, you can tell like how many sort of nails have to be available in that particular 3D space, and then and then when you, because this is a furniture, and if you build furniture, you just build it like that, you'll probably end up with this problem in structural integrity, and just doing the physical exploration over here. Is this put it over here? It's the it's a recommendation to tell like probably you should change your design into like this. But another interesting thing is using the computational intelligence to help people say like let me stop my video over here. All right, in this part. So helping them in doing their design process is very interesting, right? But then helping them, giving them choice, like, okay, you can design it and then you can, order it somewhere else, or there is some already existing products is already existing in the marketplace. Why don't you just directly buy it from them, and you can get your stuff in 3 days, right? So, so this sort of stuff, giving users a lot of more choices, and using the computational intelligence to help people do their interactivities. Right. So again, important thing is to envision what sort of usage that we need, and engineer it down to earth. And a lot of things that are useful are actually the computational intelligence part that we're using. So this is the last part of my slides, which is basically tells you how we're pushing all of these sort of technologies inside our company. Again, the e-commerce industry and all the business that we're doing is very thriving. There is a lot of interesting and fun challenges that we would like to do. We have difficulties in choosing what sort of projects that we should pursue next, because there's a lot of interesting things we can do, right? So this is our R&D organizations. We're in Tokyo, New York, Paris, Singapore, and Boston. So this is all the the business portfolio that Rakuten Inc. group have. There's a lot of different business field that we can contribute on, and we have several different offices dispersed in all of around the globe to support the business, right? And we mainly work on these 3 different research domain: power, intelligence, reality. We're basically doing all of these fields. Yeah. So in the contribution-wise, in the academic contribution, community contributions, we have increasing numbers of patents, and of course, a highly spiked increase in numbers in academic publications as well. So there's a lot of ideas and projects and results that we already did are available in the if you have access to ACM Digital Library or IEEE Explorer, or even come up to our homepage and you can find the link over there. So there's a lot of things that we're trying to do, and we're looking for our nakama, our partner. So if you're really passionate about these things and passionate to curve the future, especially for the businesses in Rakuten Inc., I would like to really invite you to join our team. So that's all the talk for me. So augmented human reality. Thank you so much. So do we have time for Q&A? Do we have? Yeah. Okay. Okay. Right. So, Laurent giving the first presentation, and me. So, if the floor have any questions, we would be very happy to answer. Yes, please, Lars.
Very open-ended question. I'm Lars from Grounded Innovation. Very open-ended question to both of you, because the first talk was about how artificial intelligence may surpass human intelligence, and the second was very much about how human and artificial intelligence can work together already now. But how do you think in the future, if we have super intelligence, will it be an enemy to the human? How can we work together? It would be like having aliens on Earth, literally. What is your
Well, if I give my opinion about that, I think what's important is to, as I try to explain in my talk, to make the difference in what, to know the fundamental differences between, which is artificial intelligence and natural intelligence, so that we decide what to delegate to artificial intelligence and what to keep for us. So, so if we talk about superintelligence as in the sense that we would have computers more intelligent than us, to me it's just that they will be more intelligent for some particular things. It cannot be for everything, otherwise, okay. It's like some scientists think that which is it will be a new species and we will disappear as the dinosaurs. I don't think so. So I think it's our choice we need to choose what to delegate and what to keep for us. But of course, yeah, the best is to combine, as Adiyan promoted, combine what artificial intelligence can bring to us and what we should keep for us at some period of time. For now, there are things we do better than computers. Later on, it will be different, but there will still always be some things we will want to keep for us, I think. Like what? Like important decisions about economics, about society, about things that are not about solving technical problems. But many people think everything is a technical problem and technology can solve everything. It's a big trend now. Most people think that.
I'm pretty much in line with what Laurent said. So yeah, there's a lot of things that the computer are very good at doing, and humans are very good at doing as well. And there's a lot of like more thorough thinking, like what is the socially acceptable solutions and whatnot, right? So it's like in economics or in politics, things like that. But as if I put my hat as an engineer, I would challenge researchers, implementers, engineers to just do not think about this yet. Just create, get your hands dirty, just create things. And if it ends up to be a super intelligence, then humans are very clever as well, and they will come up with something to cope with it. So rather than talking about being afraid first and not creating anything, it's something going to be a bit of a counterproductive. So like yes, it's a challenge, I guess. Yeah, just create it, and I think there's a lot of people in other spectrum of research going to do something else about that. So in our field, in the human-computer interaction field, actually we have a lot of different people working in different fields. So a lot of there's engineers working to make things right, and then there's a lot of people working in the social science field and trying to close the gap between the social and the technical part. So.
If I may add something, I think also what will be inside superintelligence will always be from the seeds we had put in it. So nothing will emerge by itself. I don't think so. So many things will emerge which we don't expect, and maybe incredible things. But it will always be from what we have put inside. So this is what I try to explain with the layer of the formal logics. This is something we create. So even if there is some kind of superintelligence, it will be limited by that. So we will still have some room for making other things or making things different, I think.
On that, don't we ourselves have a similar kind of constraint? Don't biological machines have the constraint of similar proportions? So do you think we can, why is it that machines have such a limitation versus a biological?
I think it's a different kind of limitation. Of course, we have many limitations. That's sure. But the limitations are really of different kinds. I think the limitations of the computers are due to the fact that there is this layer they are built on top of, and they have to do with that.
But we ourselves are built from like a biological brain.
Of course.
It's running within that. So I struggle to see the difference. Why?
Yeah. It's a different kind of limitation because we're not limited by a layer which is explicit things logical in a logical form. You cannot you can specify how any superintelligence works, even if there is some training algorithm and it discovers things by itself, but you can specify everything. You know everything about it. Even if you cannot anticipate what it will do, you know everything about it. Whereas that's what I wanted to show related to the scientific theories. You cannot explain everything. But this is really a viewpoint. I know that I can't agree with some people, and it's really a matter of opinion because it's not really scientific. I totally understand your point.
The gentleman sitting.
Yeah, so what about when the outputs that we're using right now for that neural processing have now become the inputs? So now we have AI derived from other AI, and then it isn't just the inputs that we give, it gives itself its own inputs, and it does become smarter than what we think the limits dictate.
Yeah, that's very interesting. So, if you look at the recurrent, to be a little bit of a technical specific in here, and in recurrent neural networks, there's actually it's a recurrent. So it's kind of like, so that's the whole the concept of new convolutional neural networks. It's what is different with the traditional neural network is because it has lots of layers and you can just simplify everything. But there's a lot of layers, and you can in each layer learns into different sort of features, and because of the computer resources are getting much cheaper, and then you basically now can do it. So again, yeah, using the output as an input and things like this is also what's this. The trends of these recent machine learning. So they also have the multi-layer recurrent neural network. So they have a bunch of RNN, a bunch of recurrent neural network putting in the layer. So it is very insightful to see how the model is actually working. Yes.
To make the AI super intelligent or much more intelligent than the current one, is it necessary to have like a real world experience or real world body, so then they can learn in the real world, then they can get feedback from the real world, then that could become in the end super intelligent?
The answer is yes. So have you ever tried to search something in Google, and then if you search too much, it will ask you a CAPTCHA, right? It's a number of it's basically a Google Street View numbers, which is a really hard problem. Reading a character number from a picture that's something really blurry, and they have been doing a lot of research and try to read those numbers. What they do when you fill in those CAPTCHAs is sometimes even if you input a correct input, sometimes they will ask you some other CAPTCHA. It's the source of the data for them, right? It's the ground truth data for them. So they also use all of these, the actual real world capability as their learning data, So this is just one example to actually throwing it out to find the learning data from the real world, and then use this data to retrain the model to make a perfections on the models, I guess. Do you have anything?
No.
Yes. Okay.
Just one more.
There is you speak about models. There is a curse in experimental sciences. You make some observations, you describe it with a model, and if further experiments confirm the model, you are happy.
Yes.
But you are confusing necessary and sufficient conditions.
Mm-hmm.
That's a mathematical confusion. And eventually, something will happen which will not fit in the model. Maybe. But maybe it will be a self-fulfilling prophecy, and because you interpret everything inside of the model, you will not be able to get out. So that is where the human interfere with respect to the machine. The machine will not be able to get out of the model.
Right,
the human, at some point, will say, that's ridiculous, there is something wrong there.
Yeah,
Right.
Totally agree. Yeah.
Yes. Completely agree with that. All right, if there's no more further questions, I mean, we will be around, so please join the discussion with us and just catch us. So thank you so much for giving your precious time for our session. Thank you so much.